Hello and welcome to Techie Hive. Today we will talk about another top Java interview question you can see on the screen. How does the concept of write once run everywhere applies to Java and what Java feature enables its platform independence? So by asking this question, interviewer wants to understand that you know the portability of a Java program across different platforms. Let's see answer for this question. Write once, run everywhere, often abbreviated as Vora, is a slogan, especially a marketing slogan coined by Sun Microsystem, the inventor of the Java language, to promote Java programming language. What does it mean? Unlike other programming languages like C and C++, Java programs are compiled into bytecode, which can run on any device that has a virtual machine, Java virtual machine installed. In theory, this means developers can write their code once and run it on any platform like Windows, Mac OS, Linux, Unix, etc. without needing to change the code. That means, unlike other languages like C and C++, where the code is compiled to a binary code to the executable, and that executable is platform dependent. Let's say we compile a C and C program on Windows. Then the executable generated by the compiler will only run on Windows, and same applies for other operating systems. But in the case of Java programs are compiled into bytecode. So bytecode is intermediate format, and that bytecode is used by Java virtual machine and run on the platform. So Java virtual machine is platform dependent, but the Java program is not. So uh, there exists different Java virtual machine for Windows, Mac OS, and Linux, and then this layer makes Java programs platform independent. Let's see how does it work in more detail. Here is the comparison of C and C++ program compilation and Java program compilation. Right. On the left side, you see we have C++ code, and then C or C++ code is compiled by the compiler. Let's say we are running compiler on the Windows. So we compile the program on Windows, then it will generate binary or executable specific to Windows. So that binary or executable cannot be run on Unix. Similarly, if we compile C or C++ code on Linux, that cannot run on Windows. So that means C and C++ programs are dependent on the platform. So if you are developing programs for Windows and they are compiled on Windows, they cannot be run on Unix. On other hand, we have the Java code and Java code compiles, so Java compilers compile the code in bytecode. So here, whether it's Windows, Linux, Unix, or Mac OS, it doesn't matter. The format is same. So Java compiler on Windows will generate the bytecode. Similarly, Java compiler on Linux will generate the bytecode and also applies for the other operating systems. Now, when we run Java program is run as a part of the JVM. So in the in the case of C and C++, the executables are run as a standalone process. But in Java, uh, program is executed as a part of the JVM. So JVM, takes that byte code and and runs that byte code into executable because this JVM is platform dependent. So Windows will have its own JVM, Unix will have its own JVM, Mac OS will have its own JVM. So JVM for Windows understand how to execute the program on Windows. Similarly, JVM of Unix understand how to run the program on the Unix, and the same applies for other operating system. So JVM is the layer which makes Java programs platform independent. So you have just Java program, and then you have just compiled Java program, and then Java program compiled in bytecode, as sometimes it's called, jar, is run by JVM on different platform. So that means here we are not compiling the Java program directly into executable like C and C++. Here we are compiling the Java program into a bytecode, and then JVM takes the responsibility to run that on different platform. So introducing JVM layer between the compiler and the platform makes Java program platform independent. So that's why write once, run everywhere slogan applies to Java program. Okay, that's all I wanted to cover in this video. Hope you like it. See you in next video.